Hi everyone, welcome back. Hopefully you've had some time to play with Desmos and have a little bit of a better understanding about the polar coordinate system. Well, did you know our graphing calculator knows about the polar coordinate system? Probably not, but it does. So let's take a look at how we can set up our calculator to graph with the polar coordinates. So our graphing calculators, let's see, to set it up, number one, press the mode key, which is next to the second key. So right there is mode. And then select pole and dot. So pole and dot. So come down using the down arrow key and the right arrow key to highlight pole for polar and select that. And then come down and do the same thing for dot. Okay, and then we need to press the window key, which is right here. And then make sure that theta min and theta max are set at 0 and 360. Okay, then press zoom and select Z square. So zoom is right next to the window, and then Z square is right there. Okay, so now we're all ready to type in an equation in the y is equal to window. So we can press y is equal to, and we can type any of those equations that are at the bottom of the first page. The only thing is that if an equation has an a or a b in it, we need to replace the a and a b with an actual number. So what I want to do is type in the first equation, but for a I'm going to press 3. So 3 times the square root of the cosine of 2 theta. And for theta you use x because the x key says x, t, theta, and n. So the theta will show up instead of the x when we're in polar mode. Okay, so then all we need to do is press graph and then wait. And when I say wait, I mean several minutes. Well, you can see it's starting to draw the graph. This one might not take 5 minutes, but it'll take a couple minutes to draw. So I'll set my calculator off to the side and I'll come back to it later. Okay, so now is a good time to talk about vectors because a vector is an object that has both a magnitude and a direction. So magnitude is the length here, and the direction obviously is the direction the arrow is pointing in. So geometrically we can picture a vector as a directed line segment whose length is the magnitude and the arrow indicates the direction. Vectors can be described in a Cartesian plane using their starting point and their ending point. Often the starting point is omitted when it is understood to be the origin. Vectors can also be described using an angle theta and a length r. This description is more in line with the definition of a vector, so it is arguably the most common way of describing a vector. So let's take a look at an example. We actually have 3 vectors here. We have vector A, vector B, and vector C. So this is vector A, and we can call this vector 2, 5 because it starts at the origin and it goes to point 2, 5. Okay, well, if we want to know the angle and the length or the magnitude, well, as you can guess, we're going to draw our right triangle, so the vertical angle and then the x-axis. Did I say vertical angle? I meant vertical side, and then the x-axis along with the vector forms our right triangle. And since this point is 2, 5, we know we went over 2 and we went up 5. So now we can find the length of the vector by using the Pythagorean theorem. So 2 squared plus 5 squared is equal to the length of our vector squared, so r squared. So we get the square root of 29. Okay, so that takes care of the magnitude. Now to find this angle, we know the opposite side and the adjacent side, that's tangent. So tangent is equal to opposite over adjacent. And so take the inverse tangent of both sides, you get 68.199 degrees. Okay, so that's vector A, which can be described as 2, 5, using our coordinate system, our Cartesian coordinate system. Using our polar coordinate system, we would describe this vector as the square root of 29 and 68.199 degrees. Okay, well, we can do the same thing with the other two vectors. So vector B can be described as -4, -3. Well, in order to find the magnitude and the angle or the direction, we need to draw a right triangle. And we know this point is -4, -3, so we go to the left -4 and we go down -3. And so our magnitude, we would use the Pythagorean theorem to find this angle. We would use tangent. Tangent is opposite over adjacent. So you get 36.87 degrees. Wait a second. 36 degrees is over here somewhere in the first quadrant. But our vector is over here in the third quadrant. Well, remember our bow ties? So this is telling us our reference angle is 36 point something degrees. So that means this is 36 point something degrees. So to find this angle, we need to go over 180 degrees and then the 36 point something more. So 180 plus 36 point something. That'll give us this whole angle of 216.87 degrees. So vector B can be described as -4, -3 in our polar coordinate. Oh boy, I'm doing that again. So this vector here can be described as -4, -3 in our Cartesian coordinate system. But in our polar coordinate system, it would be described as 5, 216.87 degrees. Okay, vector C, this vector here, we're going to do the same thing, create our triangle. This point is 5, -5. So we can use the Pythagorean theorem and we come up with the magnitude is square root of 50, or if you simplify it, 5 times the square root of 2. And then to find the angle, we know the opposite side and the adjacent side, so that's tangent, and you find -45 degrees. And -45 degrees is fine. So this vector can be described as 5, -5 in our Cartesian coordinate system, or in the polar coordinate system, it would be described as 5√2 and -45 degrees. Okay, so what did we do? We just converted from the Cartesian coordinates to polar coordinates. Can we go the other way around? In other words, if we know a polar coordinate, say a magnitude and an angle, can you find the Cartesian coordinates, which are the x and y values? Okay, so let's go on to the next video, and I'll see you soon.